I'll be honest, 4-7, last year didn't go insanely well. But this year I'm sure it will go great. But it's definitely a section that you want to think about and ask questions if you have them. Want to go through the steps here, kind of like these are the steps to do it. And it's kind of a good review of this. First step is largely the graph equations, just like you did before in the last couple sections. So we'll go through those. But before I get into those, I want to just kind of bring back something we did a while ago. And that was if we had a problem that said, I don't know if you don't really need to write this in your notes. But if you just think along with me, if we had x is greater than or equal to 5, there's just one variable, so our graph is going to be a number line. Yes? So now, when we do this, do I put an open circle on 5, or do I fill the thing in? I fill it in. Because you agree, x could equal 5. X could be equal to the 5, yes? So that's why we filled in the circle. Then we just have to decide, do we shade the right side, do we shade the left side? Well, numbers that are greater than 5 are on the right side. This over here, I should be. So then we'd go and we'd shade this side to show it's everything over here and the 5. Agreed? If we were to have the same exact question but have a x is just greater than 5, would I still shade to the right? Yeah. Yep, because the numbers that are greater than 5 are over here. The difference is x couldn't be 5. Agreed? So then we'd put an open circle there, which is trying to show, well, it's everything over here, everything bigger than 5, all the way down to 5, but not 5 itself, hence the open circle. Good? We're going to do a similar thing with lines, but now the difference is our new inequalities aren't just going to be x is greater than or equal to 5, or x is less than 2, or something like that. We're going to have an x and a y. So because we have an x and a y, we're going to have to do a graph like this as opposed to just a number line. You have to have a grid that has x values left and right and y values up and down. And our boundaries, instead of being just a boundary point, a boundary point that's either filled in or open circle, we have to find a way to say, well, what's our boundary going to be like if we have this line here? Well, what's it going to look like if the answer includes the line? What if it doesn't include the line? So that's where we get into these steps. So first thing, and I'll just kind of go through the first example while we go and talk about the steps. So the first thing we do is we just graph the boundary line. And I'm saying treat it like an equals. Our boundary line is going to be what's the line for y equals 2x minus 2. So it doesn't matter if you have a less than or equal to, greater than or equal. You don't worry about that sign. You just pretend it's an equals and figure out where do we put our line. Fair enough? And you could do that a couple different ways. You could do a data table with a graphing calculator. You could make like your own data table where you just pick x values and find y values. That's what I'm going to do quick a sec now. But if I say, all right, x could be 0 is usually an easy one. So if I take my x value 0, put a 0 in there, 2 times 0 is
0.
Minus 2? Negative 2. So we have the point 0, negative 2. So when we go to our graph, we go left, right, 0, then the y value, so we go down 2, so it's negative 2. That point right there is going to be on our boundary line. Yes? Now we want to pick other x values that aren't going to be too close to that, because trying to graph a line that's something like this here through like these 2 points, it's going to be hard if you're connecting those two to be accurate when you get over here and way down there. So I'm not going to do like a 1, but maybe like a 5. 5 will actually fit. It's getting close to the end, but if I take and put a 5, so x is 5, so 2 times 5 is minus 2, 8. And that's kind of the upper limit. It's kind of cheating a little bit because it's going to be right here at the edge of our number. But if I take and say, okay, so x value is 5, 1, 2, 3, 4, 5. Because it's positive 5, I go right 5. Then I go up 8, so it gets me right there at the end, something like this. 1, 2, 3, 4, 5. You okay on that one? And you could pick a third point. I heard a 3. Let's maybe do 3 quick. And if they all 3 are in a line, we know we didn't screw up. So now I do 2 times 3. So 2 times 3 is 6, minus 2? 4. So we're hoping if I go over 3 to the right and then up 4, sure looks like it's right in the middle. We good? Okay. So that so far is just a repeat of what we were doing in the earlier section. But now, before we actually draw our line in there, I want to refer back to what we were doing here, that we had this filled in circle if we had a greater than or equal to. We had an open circle if we had a not or equal to 1. So if I look at mine, it's a y is less than or equal to. So it's kind of like this filled in circle, yes? So I'm going to, in my step number 1, if you have a less than or equal to or greater than or equal to, it's a solid boundary line. Because we're going to draw a line, and we want to say that line is part of the solution, just like this point here was part of the solution before. So I'm going to slide this up, and I'm going to put my ruler on top of my graph, and I'm going to draw it just like a normal line, just something like that. So I have a nice straight line goes through my 3 points. And every point on that line now is going to be part of the solution to my inequality. Fair enough? If it hadn't been a or equal to, so going back up to step number 1, then what we do is instead of doing a solid line through there, we do a dashed boundary line. And we'll look at that in example 2. So dashed boundary line. So far, are you feeling pretty good about it so far? I'm sure it's maybe a little bit wishy-washy, but now the next thing we have to do is kind of looking like this before, decide, well, do we shade here to the right or do we shade here to the left? So we need to decide, are we shading like this section over here, kind of the up and to the left, or are we shading over here and to the right? To do that, you just need to pick any point that's not on the line. So step 2, shade one side. So pick any point not on the line and put it in the inequality. So you could pick this point here, 2, 0. You could pick like 4, 1. You could pick 2, negative 2. You could pick any point over here not on the line or any point here not on the line, yes? What I like doing is unless the line goes through the origin, I'm going to add to my little notes up there as the 0, 0. Because 0, 0 sometimes makes the math work out nicely, especially eventually. We're going to give you equations that are like 3x plus 5y is less than or equal to 12. Give you inequalities like that. If you put a 0 in here for x and there for y, what happens to that whole side of the inequality? Any number times 0 is 0. So this always ends up being 0. That always is 0. So you just get 0 is less than or equal to 12. So down the road, probably in algebra class, it'll be a whole lot easier if you just get used to using the origin. Okay, so let's pick the origin. So I'm going to try to figure out, does 0, 0, does that point right there work? My inequality. So I'm going to put a 0 in here for y. 0 is less than or equal to 2 times 0 minus 2. So I'm kind of squeezing it up there. 2 times 0 is
0.
So this side just becomes a negative 2, right? So it's telling me 0 is less than or equal to negative 2. Is 0 less than or equal to negative 2? No. It's more than negative 2. So does my point, does the 0, 0 work? No. So I'm going to see if I can... So we found 0, 0 doesn't work. So if 0, 0 doesn't work, then this whole side won't work. So we don't shade that side. Instead, we shade the opposite side. So you could either scribble it in like that, or sometimes you'll just see people do like lines kind of like this. It's really up to you. But you need to shade either the left side or the right side. So what we're really trying to say is all the points on this line work. Ignore my little circle there. I can't get rid of it easily. So all the points on my line work and all the points on this side of the line work. Does that work for example 1? So going back up, we should finish this. So pick any point that's not on the line, 0, 0 if possible. Sometimes it's really nice. Put it in the inequality like we did here. If it's true, shade that side. If it's false, when you put your point in the inequality, shade the other side. Now, one problem with doing 0, 0 for all my examples is in the homework, you're going to get at least one question where the line is going to go right through the origin. And if the line goes right through the origin, you can't pick 0, 0. So just pick any other point that the line doesn't go through. You could pick 0, 2. You could pick, I don't know, like, what would that be, like 5, 2. Just pick any point that's not on the line. Fair enough? 0, 0 just is sometimes a quicker one to do. All right, example 2. Ready for example 2?
Yeah.
Which happens to be the last example. All right, so we pretend this is like a y equals to figure out where the boundary line goes. You don't have to write it, but sometimes that's easier on your brain. X and y. If I put in 0 for x, I get a y value of negative 1. Nice. So we're doing the negative 2 times 0 is 0, minus 1, negative 1. Everybody caught up? If I put in a 3, negative 2 times 3 is negative 6, minus 1.
Negative 5.
Negative 7.
Negative 7. Yep, because you're at negative 6, you go one more negative. Go further to the left on the number line. And then let's put in a negative 3. Get another point that's not real close. And I'm just picking x values that aren't all bunched up, but what will still fit on the graph. So negative 2 times negative 3 is positive 6 minus 1? 5. And you could punch those in your calculator. You could put it in a graphing calculator, the table function. But we have these points. So now we put them on our graph. So my first point, 0, negative 1. So I go 0 left or right, but down 1. So then negative 1. And then my 3, 7. So I'd positive 3. I go 3 to the right from the origin. And I go down 7. So right there it's going to be. And now I have a negative 3, 5. So negative 3, start at the origin. Go 3 left. And I go up 5. So right there. And if you get points that aren't in a straight line, then one of your points is wrong. Go back and check, try to figure out which one it is. Now, as I draw my line in here, how do I do my line differently this time? If I have a y is greater than...
You do like the dot.
Perfect. You do the dashed line. Because it's not a or equal to, I have to, instead of doing just a solid line, I do like a dashed line. So I line up my ruler, and I just kind of do dashes, something like this here. And this is kind of like an open circle on a number line. It's saying not the line, but everything on one side of it. So everything on one side of it all the way up to this line. But points that are on this line, like this point here, negative 1, 1, looks like it's on the line. That's not part of the solution because it's on the line. You okay? So pick a point. Should I do the origin again, or you guys want to pick something weird?
Do weird.
2, 3.
We could do a 2, 3. Do 2, 3 or go to the origin.
Sure.
Or, no, 2.
We could try 2, 3. Why not? So I'm going to put a 3. So I'm checking this point here, 2, 3. If it works, we'll shade that side. If it doesn't work, we shade the other side.
I don't understand what this sign is.
Well, we just need to, we know that either all of these points are going to work in my inequality, or all of these points work in the inequality. So we're just picking a point and seeing does it fit, and if it does, we shade that side. If it doesn't work, then we shade the opposite side. So I'm going to take my 2, my x value 2, and put it in for x. I'm going to take my height of 3 and put it in for y. So I get a 3 is greater than negative 2 times 2 minus 1. So that's a 3 is greater than negative 4 minus 1 is a negative 5. So is 3 greater than negative 5?
Yes.
Yes. Because 3 is a positive, negative 5 is a negative, so it has to be bigger. So then we shade the side that includes that dot, because that is all part of the solution.